Modernize SQL Server and .NET together with AWS Transform new AI agent. I'm Khurram Khwaja. I head the product management for AWS Transform. I'm accompanied with Nits Jagannathan, product lead, and as well as Vijay Mandari, senior manager, software development. We are going to discuss about one of the problems which almost every enterprise faces, how to modernize the Windows-based applications. In this session, we will try to cover how we help through the agentic AI platform, AWS Transform, to modernize not only the UI framework, but as well as the .NET code, alongside with modernizing the SQL Server to PostgreSQL, and then deploy it on a Linux instance. We will walk you through some of the things which we hear from our customers, alongside with giving a demo of how exactly things work, and then finally taking deep diving into under the covers of how things work and how the agentic AI plays a role, as well as give some customer anecdotes, and then finally close with some of the Q&A, whichever, so that we can get feedback from you and as well as answer any questions which you may have. When we speak with our customers, we ask, what's holding them back from the modernization effort? And the answers across the customers are fairly consistent. It's not about the technology, it's not about the business, it's about continuing upgrades and updates which are required because of end of support for the SQL and the Windows Server, which requires their developers, their resources to continue to upgrade, update, and continue to patch it to keep the lights on. Secondly, the monolithic applications running on .NET framework are inhibiting their progress to adopt the cloud-native methodologies, like the DevOps, the AI analytics integration. And then finally, since it's monolithic, so you have to over-provision the applications to keep, to even accommodate for the smaller amount of the peaks of traffic. And the code is so old that even to just continuing operating that code, you have to, the troubleshooting gets bigger, patching gets much and more complex to just keep on running everything. And finally, cost is definitely a factor, as the licensing cost is one of the biggest line items in most of the IT budgets. So all of these factors combined together are holding the enterprises back to focus on innovation and just continuing to operate on this burden of the different factors. If you have transformed, if you look at the biggest blocker in this case is not just one part or the other, it's the SQL or the database modernization as well. So if you've ever gone through the migration of a SQL project along with the application, it's not a individual task. It's a coordinated task across multiple personas, across multiple different elements, which have to come together. So you start by, for a SQL modernization, you start by understanding what is the database, what are the different queries, how do they relate to the different applications, what impact will it have if you change the schema. Followed with that, you have to kind of go into the schema conversions. What is the efficacy of the schema conversions? How much manual effort is required for things which cannot be automatically translated? Then you modify the application. The application modification, in order to go through and connect to the new database or the new Postgres type of SQL instance, you deploy, validate. And everything has to be done as is done at one database at a time. So if you have a large number of databases, if you have a large number of applications, you continue this iterative process across multiple applications, one application at a time. But here comes the complexity. It's not one person or a limited number of people who are doing this. You have the SQL Server, which is being handled by the DBA. You have the .NET code being handled by the developer. Then you have the deployment and validation across other teams. So you have to bring all of these different personas together, all of these different teams together in order to make sure that it is done correctly the first time and it is repeated consistently across the remaining portfolio of your applications, which is hard. It's fragmented. Every team uses different rules. They have different scripts. They have different methodologies. So bringing everything together is labor incentive. It makes the overall, it becomes an inhibitor to do the modernization across an enterprise. This is where AWS Transform comes into play. It's the first agentic AI-based platform modernizing the full stack Windows, including the UI layer, the .NET code, the database modernization, as well as deploying into the EC2 Linux instance. Bringing all of those personas together on a single platform so that they can work together to first get the modernization done, accelerating this coordination as well as this tedious task of consistency across personas by 5x. Achieving consistency across the transformation of the different elements which make up your application, back end, front end. Making sure that it's repeatable across hundreds of applications through that single platform. And by adopting the cloud native or the modern technologies, you are able to slash open source technology, able to slash the licensing costs, resulting in 70% of the operating costs and licensing cost savings. If you kind of look at what is the historical state and where exactly is the target, you can see on the left side that we start with the assets which are .NET framework, really old code, monolithic, most of the times, using older technologies UI layer, which is their business logic, data access layer. Then you have the SQL Server, and everything is running on top of the Windows machine. Now, the target state for this is the cross-platform .NET Core 8 or 10 through AWS Transform, modernizing your UI layer to modern component-driven technologies like Blazor, MVC Core, transforming your database from SQL to open source Postgres, Aurora Postgres database, and then helping you deploy on Amazon EC2, Linux instances, EC2 or ECS. How does AWS Transform do that? It's a 4-step process which the AWS Transform does take into account. It starts by analyzing the relation between the databases and the .NET application, understanding the dependencies of the queries, understanding what SQL queries are there and how exactly they impact the application. It builds that analysis, it does that assessment, followed by the schema conversion of the SQL into PostgreSQL, doing the semantic analysis to make sure that it conforms to what you had in the SQL. And then even you can migrate the data as well using our Amazon DMS service, data migration service. The second part of that, the third step in this is where the dependent application code is modified with the connection strings, with the ORM, and any other SQL dependent application code so that it can start communicating or start working together as an application with the PostgreSQL, which is finally deployed, deployed and validated on EC2, Linux, or ECX instance. To give you more to what exactly and how exactly it does, I'm going to request Nits to come over here and show how these things that work. Nits?
Hey, everybody. My name is Nits, and I'm product lead for AWS Transform for Windows. All right. Before we go into the demo, just want to get a show of hands of how many have played with AWS Transform, or do you have some familiarity with it? Okay, all right, I see a couple of hands in there. Okay, good. So for folks who do not have, have used AWS Transform before, let me just quickly set the context on how do you get there. This is a recorded video, so I will click through and stop at the specific points and explain what's happening in each of those stages. So, all right, I have the fun part of the job. I'm going to go through a demo. This is the first time for some of you where you'd see a full end-to-end experience across the whole stack. You will modernize your .NET framework applications to .NET 8 or 10, and then we will also show an experience of how you can move from SQL Server to Aurora Postgres as well. Okay? All right. So first thing is, what you see here is the AWS console, and in order to log into this, you have multiple options. You can either create your own identity center or use your own IDP providers to log into that. Use your credentials, and the first thing what you will be faced with will be a workspace. And workspace is a container for all your .NET, SQL, modernization jobs. And the first step you do is create a job, right? When you create a job, there are multiple different agents, different capabilities. For example, in this case, you see a mainframe modernization agent. And for this particular audience, this is a Windows modernization, right? So you come here, you select the Windows modernization, and you are faced with two options. One is a .NET modernization, and the other one is a SQL Server. So in order for customers to migrate their legacy applications, the first thing they have to do is modernize from .NET Framework to .NET 8 or .NET 10. So the first part of the workflow we will see will be transforming your .NET Framework applications to .NET 8. And then after that, we will take that same application, we will run it through transforming application and SQL Server together so that you get a fully modernized stack. Okay? All right, you select the modernization piece. And what you are faced with here is essentially the transformation plan. This is the high-level plan which AWS Transform thinks are all the steps that it's going to take to transform your .NET applications. We will first connect to your source code repos, and then we will assess and identify dependencies across your repositories. If there are repos that are dependent on other repos, we will create that dependency mapping, and we will do all the transformation. And if there are private NuGet packages, we will transform those as well. And you will have the option of selecting whether the target should be .NET 8 or .NET 10, or even for some of your class libraries, you want to leave them to .NET Standard, you have all of those options to pick. Okay? So the first step here is definitely setting up access to your source code connector. We support two mechanisms. Either you use code connections with your GitHub, GitLab, Bitbucket, or Azure repos, or you can upload source code directly using your S3 buckets. Okay? Then after that is set up, what we will do is we will go and look at the repositories in your account, right? And then here is where you get a chance to select them, which branch you want, what's your target you want, and this will allow us to perform assessment, right? If you have hundreds of repos and you want to transform, let's say 10, you select these ones and then let the process go. Okay? So you select the specific repositories you need and then send it for transformation. And what we are showing here is the private NuGet packages. So if you have private NuGet packages, we support two mechanisms. One, if you have Azure artifacts, where all your private NuGet feeds are, you can directly interface with that. Or what you can do is you can download a script from our side and then run it on the same machine as your Visual Studio. And we will collect all the dependent packages as one zip file, and you can upload it there. All right? So then, you can upload those package files, and that way we will be able to resolve all the package dependencies. And finally, you get to review, here are the set of your work. This is our transformation, I would say, input, right? The repos that we want to transform, any dependent repos, and dependent packages, right? And then this is when you review it, accept it, and send it to AWS Transform to modernize. And once the transformation starts, it is essentially an agentic workflow where it will start identifying, which is the order in which we want to transform, and we'll start going through each and every project and in those repositories. And you can use the dashboard to check the status of what's currently happening, right? If there are any failed repos, you will get a transformation summary of why we are not able to transform it, and with the corresponding next steps on how do you fix those. Right? And then you can feed those into your coding assistants like Kiro to complete those jobs. And then you can come back and run further transformations as well. Yep. So that is basically the .NET, like framework portion of the conversion. So what it means is that like at the starting point, you have a .NET framework, you go through this process, at the end of it, you get a .NET 8 or .NET 10 application. And that becomes the next stage of the pipeline, which is the SQL Server transformation. And this is also, it starts with the same, right? Like you create a job as you did before, and you select the Windows modernization as always. But in this case, instead of .NET modernization, actually, give me a second, sorry. The SQL Server, you create a job, you come back into Windows modernization, but instead of selecting the .NET, you will select the SQL Server as an option, right? And as now it will be familiar with the same kind of sets in the transformation plan, but here you would notice significant differences between what you saw at .NET versus here. The job plan has we are validating permissions and we are making sure that we have the right access to your databases. You have the option to review databases and repositories together. And before doing all of those assessments and wave plans and things like that. And Kuram was pointing out in that flow where the sequence of assessment, which has we identify all the repos, all the databases, identify dependencies between them, create wave planning, and then after that we do the transformation. So the first step is definitely the prerequisites that is needed. Because we are dealing with databases, we want to make sure we have the right roles, the permissions, and accesses to the right accounts. So once you validate all of it, you get started. And here you approve the connector, and first the database connector, where your AWS account, where all your databases are installed. And then the next part will be the source code repositories that you will be installing them. And after you do all of that, essentially, give me a second. Yeah. Oh. Give me a second. Sorry, the video is, I might need to go back. Oh. Selecting the, there you go. Apologies for that. Selecting controls within the video is challenge, so we'll go again from the beginning. So, but yeah, it's fairly short video, so you will go through it fast. So yeah, here select the job, go through it, and as we go through the source code connector, and we will go into the assessment, I will stop and talk a little bit more. Right. So you get to the prerequisites, and after that, you'll go into the database. This is where your AWS account. And after, you need to send it to an IT admin for your AWS account to approve it. And after that comes the source code connections, where your source code repositories that you transformed before, and you're able to use both of them together. So that's the true power of the full stack modernization here. You can go change the applications and the databases. Right? And then you have an optional deployment. If you want to deploy those transformed applications, you can do that as well. Okay? So once all the connector stuff is set up, we will basically, what we want to do is we want to run a validation of all your permissions, making sure that we have the right level of permissions, the roles, all of that. Okay, the permissions are checked, everything is good. We would first want to go do a discovery, making sure in your AWS account, are we able to identify the servers and the corresponding databases, and along with that, the repositories as well. So here you will have the option to select which repositories you want to transform, which databases you want to select, all of those. Right? Then you approve it for assessment. And as part of our assessment, we will go and identify the dependencies between the apps, the databases, and we will create those wave plans that we talked about. You will see those. Like here in this case, you are able to see 2 waves. Each of those waves have one database each and one repository each, because they have a dependency relationship. And because they are independent, you have created 2 waves, and they will be transforming independently. And that also keeps separation between which teams have to collaborate together and which teams have to work together to resolve those. Okay? And you can download the waves and you can edit them as well if you think there has to be more dependency relationship that you have to adjust. Right? And then the first part of the transformation is schema conversion. So for the SQL Server to Postgres, what we want to do is we want to take a look at your server and then identify all the database schemas, and we would want to make sure that we are able to transform them into Postgres compatible schemas. So the schema conversion goes through by leveraging some, the existing AWS services with like AWS DMS schema conversion service under the hood. We will do the transformation, and we will use the target cluster that we created, and we will target schema conversion for that. Once the schema conversion step is done, essentially, like that's when like the rest of the code transformation and the migration will come. So in this case, you can select which one of those, like target clusters. And you can also download, and you want to make changes after the schema conversion portion is done. Right, like, so we will do the schema conversion using the generative AI mechanism. We will identify schemas in SQL, convert them to Postgres, run a self-debugging loop. If we identify issues, we will fix those. And at the end of it, you will get a summary of all the things. If it is fully transformed, in this case, we'll say it's fully transformed. If it is not transformed, you will basically be able to see, like what functionality we are not able to transform, and you can leverage our transformation report to go fix those yourself. Okay. And then the next part is the migration of data, right? Like, so whether you would want to validate this by migrating a snapshot of your database into the target cluster, that's an optional step for you. If you want to do it, you can do it. And we are leveraging an existing AWS service, AWS DMS, and we have a deep link into the console if you want to go check the status of what's happening there as well. So in this case, like the data migration is completed. And then this is the step where like code transformation is happening. So if your application has entity framework or ADO.NET code, which is using the ORM to interact with your database, we will make the corresponding changes in the application pointing to that. Right? So if you have embedded SQL, you have connection strings that needs to be updated, or or ORM, all of those things are transformed by AWS Transform. And that actually it saves application developers a lot of time because they don't actually have to go work with multiple DB teams to try to figure out like what's the schema updates happen. So it reduces a lot of back and forth. Okay. So one of the things that we ask for is a feature branch where we would commit those code changes for your application so that your original source code is not updated. All right. So in this case, we would basically like select, and all the transformation reports are available. And finally, essentially, deploy the stage. And you would use a deployment connector to make sure that like we are deploying it to the right AWS account. And with that, essentially, you can set the target, whether you want an ECS or EC2 instance as your target. And you can select those parameters. And once that is sent, we will basically like deploy those applications into those accounts. Right? And now you have at the end of it, you have a fully validated mechanism where you can have apps that are transformed to your Postgres. You have a Postgres database with your converted schemas, and you can combine them together and run through validation. Right? Like, so that's the powerful functionality that you have in a single workflow here. All right? That concludes the demo, and I was able to show through a high level of how it works. And now we will show you like under the hood exactly like what we are doing, so that like you have more comfort in terms of what we're doing as a service. And for that, I'll invite Vijay.
Thanks for the demo. As you've seen how the product works, wanted to take this opportunity to talk about how our service works under the hood. Before I get started, quick show of hands. How many of you have experience working with agents, agentic systems, MCP tools? Quite a few, right? So this should be pretty easy. So under the hood, all of this. So this is a complete agentic AI solution that comprises of dynamic and goal-seeking agents. The center of this multi-agent framework is a Windows modernization agent, which acts as the brain, orchestrating the entire workflow end-to-end. It uses something called as connectors, and these connectors act as a bridge between customers' resources, AWS account, and the agents, right? So there are three different connectors that the agents primarily use. The first one is the source code connector, which acts as a bridge between the source code repositories and the agents. The source code connector under the hood relies on another AWS service called as Code Connections, which provides a safe and secure way for the agents to interact and download the source code, download the code from source code repositories. Then we have a database connector. The database connector is configured with all the roles and permissions that are needed to access databases in a customer's account, discover them, assess them, transform them, and it also has access to all the secrets using which the agents can connect to both the source database as well as the destination Postgres SQL database. Right? And then there's also a deployment connector that has all the roles and permissions that are needed by the agents to spin up instances, spin up EC2 clusters, build the application, transform and move all the transformed binaries into these ECS clusters and actually run them. Right? So the orchestrator agent also has access to a few specialized agents. Some of them are like the assessment and planning agent. The responsibility of this agent is to assess customers' portfolio, to figure out what applications are running, what databases they're talking to, and generate a dynamic plan. The plan is basically customized based on what these agents are finding in customers' environment, right? Depending on the version of the applications, how many databases they're talking to, for instance, right? And then once a plan is built, the schema conversion agent is primarily responsible for migrating all the database objects across, convert the SQL Server database objects like tables, stored procedures, views into the Postgres equivalent versions. And we also, the orchestrator agent also has access to an MCP tool which does all the data migration. Once the schema is converted, then the data can be migrated from source to destination. Then there is a code transformation agent which primarily identifies, based on the nature of the applications, the underlying frameworks that are used for queries, and then transforms the SQL queries based on how the objects were converted, transforms the code, and then commits it into a specific branch, right? And the deployment agent is capable of taking this code, building it, launch necessary EC2 instances or ECS clusters based on customer preferences, and then copy this binary across and then build and run the application. So this system is completely agentic. All of these agents and tools come together to basically make the workflow dynamic, right? Based on the nature of the applications, the version of applications, the number of databases they're talking to, the plan is catered and the plan is generated based on that customer preferences. And all the interactions that customers have with the system are led through chat. The orchestrator has access to a chat agent which enables customers to provide natural language queries and provide the necessary answers to them. So the chat agent has access to an underlying knowledge base which encompasses all the AWS knowledge as well as how the job is progressing, all the reports that are generated through the process, any errors the system runs into, all of that is committed to the knowledge base so that the chat is able to provide guidance to the customers on what the next steps are, right? So it has access to some of the common errors that customers run into and can, whenever there's an issue or an error, it can provide guidance on how do you unblock yourself so that you're able to move forward, right? You don't have to go ask. Chat is pretty interactive. It knows where you are in the system and what you need to do next and provides you the necessary guidance. And the workflow is completely composable based on customer preferences, right? You want to migrate data, you don't want to do that, you want to do deployments, or you want to take control of the deployment process. The entire modernization journey is customizable. And even though these agents are capable of making decisions, they also provide visibility of what they're doing and provides ability for customers to inspect and interject as needed and control the overall modernization process through HITLs that it generates. So now, as we've looked into the overall system, let's dive deep into each phase. The first is assessment. The assessment and the planning agent have access to the source code repositories and databases. They use the source code connector as well as the database connector to first validate that all the prerequisites are properly set. In case any prerequisites are missing, through chat, it tells the user on what the missing pieces are and how to fix them so that the job can be successful, right? And once the prereq validation is done, it does a discovery. It goes and identifies what are all the applications that are configured in your source code repositories, and it also goes and discovers all the databases that are running, and then tries to do a mapping between which applications are talking to which databases. And there are a few ways in which this is done. The agent tries to parse the source code and then figure out if there are any connection strings configured, or if, are there any environment variables that are set up in pipeline that can help identify which application is dependent on which database. And then it also has a fallback logic where it tries to identify the database objects that are referenced in code, like for instance, stored procedure names, view names, or table names that are being used in code. It is able to go detect that in your source code as well as detect that in your databases and then kind of create a cross mapping between these two. And then it creates logical units, a logical unit of like dependent applications and databases that should be transformed together. Right? And once these logical units are formed, the agent tries to determine the overall complexity of transforming this logical entity from SQL to Postgres. There are different factors it uses. The factors like how big is the source code, right? The number lines of code, as well as the number of objects that are present in the database, how compatible they are between SQL and Postgres. Based on this, it tries to compute a score, and then once it computes a score for each of these logical unit, it creates modernization waves. Each wave comprising of a logical unit of dependent applications and database together, databases that should be transformed together, right? And this system being completely agentic also gives an opportunity to the customer to express their own custom preferences on how they want to transform the order in which they want to do them. They can express that through natural language, and the agent kind of goes in a loop, adjusting the wave plan based on the user needs. And once that is done, and throughout the process, a lot of assessment reports are generated, and if the agents are running into any errors, all of that data is consistently stored in the knowledge base so that the chat agent can continue to tell the user on what to do next or how to unblock themselves. Once assessment is done, the conversion process starts. There are 3 steps in converting a SQL database to its Postgres counterpart. The first, the agent connects to the source databases, fetches all the networking information, figures out what all the roles that are needed to launch the target database. Based on the networking information it gathers from the source, it creates a destination cluster and configures the Postgres cluster so that the agents can talk to them and then create all the database objects. Once that is done, the orchestrator uses a schema conversion agent that actually starts the conversion process and converts tables, views, and stored procedures into the Postgres counterparts. And the agent is also equipped with some of the complexities of this conversion, some of the common errors that customers generally run into, and it has examples on how to fix them. Using these examples, it goes into like a self-debugging loop, trying to generate the required object, validate it, and if the validation fails, regenerate it based using LLMs, and until the validation is successful, right? And the way the validation works here is once the corresponding Postgres objects are generated, it does syntactic validation so that the created objects are compatible with what Postgres expects, right? And during this process, it also generates a mapping file, a mapping of what were the source database objects and what were the converted database objects. This mapping is important for the agent to also update the corresponding query in queries in source code. So once the schema is successfully transformed, this is an optional step. The orchestrator agent has access to an MCP tool, which under the hood uses database migration service to move the data from SQL to Postgres, right? So once the database conversion is successful, the orchestrator starts the code transformation process, and for the code transformation agent, it uses the application source code as well as the mappings that were generated between the source and the destination database as primary inputs, right? And there are different patterns in which applications can interact with underlying databases. The most popular patterns are using either entity framework, or if they're older projects, then they typically use ADO.NET. So the agent, based on what it figures out, if an application is using entity framework, then the agent is capable of understanding how the application is built update the corresponding entity bindings for them to work with the destination database. Before any and this is also an iterative process. It uses LLMs to figure out what changes need to be made. There are different ways in which entity framework can be configured. Some of the popular patterns are either using annotations or API invocations, or there are also XML binding files, XML configuration files that have information about how these bindings are maintained between the source code and the database, right? And the agent can figure out these patterns and automatically update the code to make it compatible with Postgres. And once the validations is done, and let's say if in case of applications that are relying on AD or .NET, the agent parses the code, identifies the corresponding SQL queries, extracts them, and it first uses a rule-based engine to transform these extracted queries into Postgres, and then it also fallbacks to a LLM-based model where it generates Postgres queries, validates that the queries are accurate and are working in the same way. The validation is two-phased here. It first does a syntactic validation to ensure that the Postgres query is syntactically correct, and then it also does a functional equivalence validation where it relies on formal verification mechanisms to ensure that the query that is generated in Postgres is functionally equivalent and is generating the same kind of outputs that the SQL query is generating, right? And once the transformation is complete, the agent has now done validation on the queries that are transformed. It also has to ensure that the surrounding .NET code is working as expected, right? And for that, it does a .NET build of the application once the queries are replaced. And if the build fails, it goes into a debugging loop where it tries to fix build errors, generate new code, and then retry the process until the build succeeds, right? And in this process, if the agent finds that there are unit tests associated with source code, it also builds the application and then runs those unit tests. And once they're successful, it commits the transformed code into a new branch. So once the code transformation is complete, then the deployment process kicks in. The deployment agent primarily takes the transformed source code from the target branch, launches an EC2 instance, and it builds the application. And once the application is built based on customer preferences, it either launches an EC2 Linux instance or it launches a ECS cluster configure set, copies the built binaries into these and brings up the application. And then it also does a couple of validation steps to ensure that the application is up and running. First, it does a health check whether the application is reachable. And the second thing, it also does a connectivity check between the application as well as the underlying databases so that customers can continue to test using either an automated test suite that they have or manual testing that they can do, right? This is an iterative process where customers can continue to check out the code, make corresponding changes, commit it back to the branch. Agent always picks up the latest code, builds the binaries, and copies them back to the launched EC2 Linux instance or the ECS container so that customers can continue to test this. So this is a high-level overview of how the Windows full stack modernization works. And to talk more about, based on how customers have been using so far, how using this system so far, and the feedback that they have, Khurram is going to talk about that. Cool.
Thank you, Vijay, for two things which I want to highlight. One is that this full stack modernization is available for SQL, which is hosted on EC2 Linux and the RDS today. And second, which is a more important part, is this service is available at no cost to you. You don't pay for using these agents. You only basically pay for the resources which you use, like the EC2 instance or Postgres cluster. But the whole agentic workflow, the access to it through the AWS transform is at no additional cost. Hopefully that kind of gets you excited to try it out, okay, and take the first step, next step. Based on our customer feedback and what we have been working with, and Verisk is one of them, which has been in the industry, insurance industry, providing technology solutions to the customers. So they expect that with this combined full stack modernization, they can really see the output, accelerating their modernization timelines by 4x with achieving the cost optimization of about 40%. Team front, Another customer who had a really, they have been an early adopter of AWS Transform for .NET. They were able to transform their monolith application from framework to core. They even participated in our beta for UI-based transformation, were able to take their web forms to Blazor, and they're now looking at the SQL to work together to do the complete modernization, which will help them do the full stack modernization as a combined step instead of multiple steps. And Commonwealth Bank of Australia, again, they are looking at the overall transformation of how they can accelerate it. And with AWS Transform, they see a path which can help them achieve their objectives instead of years and months and years of effort. We have been working with some of our launch partners who have been helping us out or working together with us on the database migrations in the past. And Kalen Technologies, Presidio, Evolve, Tech Systems. And the key thing which we hear from them is that bringing together the code alongside with the database modernization is something which will help them accelerate, work together with their customers in a more effective and more optimized manner instead of moving across multiple steps of the transformation across different personas. From our request is please scan those QR codes, go to AWS Transform, understand more. There is interactive demo. You can look through it, how exactly it works. You can have more specific sessions on this one. There is a workshop. There are a couple of workshops which we will walk you through each and every step and how exactly the full stack modernization or the .NET code as well as the SQL transformation works. Attend them, get your experience on it. If you want to get more in-depth information, you can go, if you scan the QR code and look at the skill builder to get trained on it. But ultimately, we are here to work with you. So any feedback, any comments, anything which we should be doing better or we should be able to help you address, reach out to us. We are always available, and we will work backwards from your requests. Thank you, and we will be able to now take questions and listen.